Well, welcome. Today I'd like to talk about NodeEdgePoly. NodeEdgePoly is a C++ topologic spatial data store, which means it's a set of C++ class libraries that implement a topologic geographic database. Specifically, I want to show you an application called TigerDB, which is a sample database application, which is built on top of NodeEdgePoly. For data in this system, I'm going to use the US Census Bureau Tiger line files. Now, I use these files because they're a rich source of geographic information, and they're topologic by nature. They contain lines, points, and polygons. I'm also going to use the Geographic Names Information System, or GNIS, to show some point data with names in it. Now, to show this data, I'm going to demo an application called MapViewSD, which is a MFC C++ application written on top of TigerDB. So that's what I want to show you. And but before I do that, I want to talk a little bit more about topology. So the topologic model that I use in NodeEdgePoly is a real topologic network, and it's implemented in a network database, not a relational database. So what do I mean by that? So this model here, which is actually shown on my website, has 3 edges in it, E1, E2, E3. Now each edge contains 2 nodes, and you can see that with these black lines. The node 1 and node 2. One is the start node, one is the end node. All right. So every edge has a start and end node. Now each node can have more than one edge coming into it. So it has another set of links. Now these little lines here are links, and they are the links that hook into the various nodes, or I should say various edges, all right? And over here in blue, we've got one polygon, and polygons are also links. They're links to edges. So in NodeEdgePoly's topologic model, we don't duplicate shapefiles, all right? I've shape coordinates, as in the shapefile model that's implemented by ESRI. So we try to minimize the duplication of data in a database for obvious reasons. And I'll talk about this more later when I'm demoing the data. So you don't need to worry about this model, but I just wanted to give you an appreciation for what's actually going on under the hood, because the Tiger line files don't have this actual network built for you. What the NodeEdgePoly system does is it loads the raw data in, and it builds these node edges and polygons inside the database. All right. So I just wanted to present that as a simple introduction before I show you the actual application. Now, before I do that, though, I'd like to show you a very simple Microsoft Access database, which contains text data. Specifically, it contains names, all right? So the first table we're looking at is the dist names table. And what it is it's the distinct names that come out of the Tiger line files for these line features. And we don't duplicate text either in this database. That's why we call it distinct names. Now, the GNIS names are the names that come out of the GNIS data system. And so these come out. And what this data represents is 2 counties in Maine. And I'll show you that in a second. So now, why did we put this data in here? Well, we put it in here for several reasons. One, I didn't want to clutter the geographic database with text. Now, I can store text in the geographic database, but I don't want to do that if I don't have to. But also, there may be other data that I want to link to, statistical data or block data or census data or any kind of data that I might want in a relational database. So you can link to it easily because you're developing this at the C++ level, so you can kind of do what you want to do. All right. So without further ado, I'm going to show you MapView. So I have built a database with, as I said, with 2 counties in Maine in it, Knox and Waldo. So this is the spatial information that's coming right out of the spatial database. Now I want to zoom in a little bit and show you the data at a better level to see things. Now, one thing, I'm going to go through some of the features of this application, but before I start on that, I want to explain to you that this program is not a GIS. It has GIS functionality in it, but it's not a GIS per se. And it's also not a professional mapping system, meaning I can't use this software, to make pretty maps. But its sole purpose is to really demo this TigerDB and the NodeEdgePoly system and show you how you can build an application from it. So the first thing I want to do is I want to turn on some more layers. So these are just some basic layers that are hard-coded from this data. So I have my line data, I've got my point data, which I store these GNIS names in, and I have my polygons. So I'm going to add streets, which makes for a more interesting map. And I'm going to add this census data here, which shows a lot of place names. So I'll go ahead and turn that on. And now you see we've got a bunch of more local roads, and we've got a bunch more names. So that's easy to do. And while I'm zooming, I'll just show you. I support the standard functions for zoom. Like I can zoom back out. I can zoom to the. I'll zoom back in. Now, one thing I wanted to let you know is when you run this program, you don't have to go into a certain mode to do zooming, to panning and zooming. You're in that mode. You can just simply select with your a rectangle and redisplay the data. So I can zoom left, and then I can zoom right. Actually, what I did is I zoomed out. I'm going to zoom right now. Okay, so here we are. Now let's go ahead and zoom back into the Belfast area here. Now the first tool I want to show you is the Object Info tool, and all it is a simple picking tool. So I can go into my line data and I can pick a line segment or an edge, what we call an edge, and you'll see that it displays some information here. Now the ID that I'm looking at is actually the Tiger line ID. So the nice thing about the Tiger data is it has a unique ID already built into the data for every edge in the whole entire system for the United States. Now, I store that in a field inside of NodeEdgePoly called the user ID. And so you can use any ID that you have, provided that it's unique. And then this other number here is the actual database record number. Now, the second field is the name data. So you can actually see, and this is the data I showed you already that's stored in the Access database. I don't store that in the geographic database. So this little segment here has 2 names. It's Belmont Avenue and State Highway 3. And it can have up to 5 names. And then the third field is just the type field, which tells me that it's a primary road or a US highway. Now I can pick other features like I'll pick that stream. Now that's telling me that's Duck Trap River, and it's also giving me the ID again. I can pick different features here. All right, here's another. This is a state highway, and so it's a pretty nice little feature for picking things. Now, one thing I wanted to point out to you, if you can see this, well, let me pick another line here. So it's really obvious what, I'll pick this guy. Now you see this blue line, that's the line I just picked. Now you see the little marker symbol at the end of the line. Well, that tells you the end node, all right? So as I said, there's a start node and an end node. Well, that tells you the end node, and that shows you the direction that the coordinates go in, all right? And that would be the positive direction going towards the end node. So that's just a nice thing to be able to tell you, because as I mentioned, the topological model keeps this these directed, what we call directed edges, which are links to the nodes of the edge, and so that a node can either have a forward direction or minus direction. Okay, so that's just something I wanted to mention real quickly. So I'm going to turn off this this object info dialog. Now I've already shown you the layers. I do have one other little. I played around with map projections a lot. I don't have a lot of map projections supported here. And I'm just going to show you one, the equidistant cylindrical projection. And you can, I don't know if you can notice that, but I have a slightly different projection now. Let's go back. Let's zoom in a little closer. All right, now what I'll do is I'll turn that off. And I don't know if you can notice that, but it changed a little bit in the X direction. So I may do some more work with map projections at some point, but that's wasn't really the focus of my work. So now I can also, I've got a nice little tool that I can use, which allows me to search for features. Now, before I do that though, I need an ID. Okay, so I'm going to take this ID of this Weymouth Road that I had selected before. Now I'm going to go in and I'm going to press the search function. So what I'm going to do is, in this case, I'm going to search on a user ID. All right, so remember in this case, I'm using this TLID, but this can be any user ID that you have. Now, what this does is this goes out, there's what I call the direct access file that's part of the system. And what it does is it hashes the ID, and it allows for very quick lookup of the record number. So what it does is it will do that when I press OK. So it goes out, it hashes that value, and then looks it up in the hash table, and then displays it. Now it zooms way in to the feature. It puts the feature right on the screen. So I want to zoom out a little bit here, just to show you that where we are. But it's a nice feature for being able to look at features. Now, again, you'll notice the marker symbol, which is showing you the direction of the coordinates. As I said, I can search on other things too. If I have no name, of course, I won't display any name. So I just wanted to show you that. It's a handy little function, particularly when I was debugging this data. I use that function a lot. Now, let's see, I've shown you that. Yeah, I want to show you the thinning tool now, but I want to zoom out a little bit here and go to the coast. All right, so I want to pick this over here. I still want to zoom out a little further, and I want to pick this. All right, so what I can do is I can thin the lines on the fly using a distance tolerance. And what this tolerance does is I'm utilizing what we call a trend line algorithm. So I'm trying to get just the trend of the line and sort of remove the unnecessary points. So let me go ahead and do that. So I don't know if you can see what's happened, but so I'm filtering out a lot of the nodes, and now the trend of the line is becoming more prevalent. So what's interesting is about this tool is, let's make this tolerance a little greater and see what happens. All right, so now I get a very radical amount of thinning. Now where you really see this is with the polygon, because it has a lot more points. So the polygon itself is linked to these lines here. It's linked to the shoreline, but you can see it gets thin differently. Let me zoom out. Let me zoom out one. Yeah, you can see how the trend for the water and the island is different now than the shoreline, and that's just simply because the edges are much smaller, and so this great big massive hydro polygon is getting thin differently. So I want to turn that off, because it's not something you really want to look at. Where I've used this functionality is when I'm trying to, if I I've written line matching methods before, and it helps to match the line by just looking at the trend and not having to deal with all the shape points. So that's actually where I've used this tool in real life practice. So I want to show you another tool called the shortest path tool. And so what this shortest path tool does is it finds a network, a road network. Well, actually, I'm using the road network. It will use any type of line, all right? But in this case, I'm just interested in shortest paths along my road network. So I'm going to turn that on, and you'll notice at the bottom, it tells me to pick the first edge. So now I'm actually in a mode now. I'm actually in the, the shortest path mode. So I'm going to pick this edge here just because it looks good. And then I'm going to pick an edge way, way, way down here. All right. So we'll see what happens. And it's also telling me that I need to pick a second edge here. So I'm going to pick that edge. And I don't know if you saw that, but there was a blue line of shortest path that was calculated. Now, you'll notice that it deviates from the primary road here. And you can actually control that in the shortest path tool. It's a tool that you can use. Now I've got it sort of it's hard coded right now in the application. In a real application, I would allow you to really set that tool up in more elaborate format. But what I want to point out to you is this tool is using that topologic network. It's using those links. So it's going out, it's starting at the beginning, and it's moving its way towards a destination point, which is one of the nodes on the second line that I picked. And so it's kind of moving its way towards there, and it's picking the edges, but it gets those edges from the nodes, all right? So it gets one of its nodes, and then it looks for the edges around that node, and then picks another one, and then it uses that, and then it uses that until it finally comes down. I don't know if you notice, it's quite fast. Now you might say, it isn't that fast compared to some other system, but there are a lot of edges in this system. All right, more edges than would normally be like say in a Google Maps system. All right. So it's actually doing quite a bit of work there. So anyways, the shortest path is a cool little tool, which I like to use. I think it's fun to use. And it's there for you to write applications with. So I'm going to turn this off right now. Now, one thing I want to talk about again, I talk about this a little bit. The data that I'm using for this line data is, as I said, is Tiger line data, but the polygons, there's kind of two separate sources of polygons in Tiger line files. There are these things called landmark polygons. So if you look at the green here, these are actually pre-built designated polygons, which actually tell me what the line borders are. So you can process those files. They have a bunch of different types of polygons in landmarks. They also have landmark points, which I have not loaded into the system. But the hydro polygon and the island polygon are not from those landmarks. They are from the US Census block data. Now, a Tiger file comes with all these breakdowns of divisions of things, which we call tracts, block groups, and blocks, okay? And they relate to the statistical sort of part of the Census Bureau. But the water blocks are marked a particular way. And so to build these nice big blue polygons, or what I call hydro polygons, I'm going to zoom out even a little further. I have to process the blocks, okay? So what I do is I parse those Tiger line files. They're just ASCII text files. And then I load the blocks into a relational database. And then I process them by going through and picking an edge. And then again, using the topology, I search around until I close. And so that's what I've got here. And if I've got a positive area when I'm done, I've got a hydropolygon. If I have a negative area, I have an island. So the islands aren't they're not a separate type of polygon. Okay, they're just the result of the fact that the blocks of the water, don't go over the island. So that's how I made these island polygons, was from this block data. So that's another cool thing that's in the Tiger. And there's more stuff in there too that again, this was just meant to be a sort of a demo. Now, I mentioned this TigerDB thing. This TigerDB thing was created just through using C++ inheritance. I just simply inherited from the NodeEdgePoly system. I made a few customizations, which really just pertain to the text that I show you here. That's really the only customizations I had to make. And that's how I built it. Now, the source code for this application and for the TigerDB are out on GitHub. And presumably you've come to this video through my website. So I have a link on my website to this repository. I also have a program that I used to build this data from the Tiger data. It's called TigerTrans. That's also, there's also a link to that out on the repository. This is open source code, which you can download to look at. And I highly recommend doing it because it shows you exactly how the system works. I also, the MapView program, if I didn't mention this already, is also in a repository, which you can download. So that's open source. Now, the NodeEdgePoly system itself is a proprietary system, but I license it for free. I license the debug Win32 libraries for free. All you need to do is register on my website, and you can download, well, for one thing, you can download this whole sample application along with this same data file and play around with it. You can do that. You can put that on your computer. There's a few things you have to do to get it to work, but it's not that hard. And then you could download the whole NodeEdgePoly system, including all the header files, the DLLs, and the link libraries. I'm sorry, not the link libraries, but the libraries that allow you to link to the DLLs. And then you can start building your own applications. You could actually build, you could build this MapView program and run it. So that's about everything I wanted to cover and really quickly. And the only other thing I didn't show you is I can go in here and I can turn off, whole groups of data categories. So I can just, if I want a sparser map, I can just look at, I can turn off the polygons and the points. Now that's pretty much all the points. I'll turn on a few other ones. There are some other points which will show island names and stuff like that. So again, that's it. NodeEdgePoly, come to my website again. I have a lot of documentation there, and you can actually build yourself a spatial application. Now, you might ask, well, why do I want to do that when I can go out and buy a GIS system? Well, remember, this is at the C++ programming level. So you have ultimate control in how your objects, what data gets stored, how it gets stored, how you link things to relational databases. Now, by the way, I didn't mention I use ODBC to link the two things together, but you can use any technology you want. It doesn't really matter what you use. I happen to use ODBC because it's built in to the MFC libraries, which I'm using. And but you can use any database. I do all my development of databases using SQL Server, and then I copy the data to an Access database. You could use SQLite or any database you want to use, you can use. Okay, so that is the system in a nutshell, and I am going to stop recording.